OffLecture. Learn beyond class.
Introduction to Global Time. Welcome to a journey across our spinning globe to uncover the secrets of global time. Imagine the world as a highly relatable global time puzzle. Today, we will discover how global time works, unlock the mechanics of Earth's rotation math, and master the global rules that keep our world connected. One Earth, different moments. Think about a single moment. While you are enjoying breakfast in one global city, someone across the world is heading to bedtime. Why do their clocks disagree when it is the exact same moment in time? This secret is entirely driven by how our Earth constantly spins, creating entirely different local times. The 24-hour spin. To understand this movement, let's look at the math of our 24-hour spin. The Earth rotates a full 360 degrees every single day. If we divide that journey, every 15 degrees equals exactly 1 hour, creating a 15-degree slice for each hour. Sunlight interacting with this rotation creates our daily time. The universal starting line. Every global clock needs a universal starting line. This baseline is the 0-degree longitude reference line, a global baseline where time officially begins. Passing through Greenwich in England, it splits the Earth into east and west hemispheres, helping us calculate local time across the world. East gain, west lose. As we move from this baseline, remember the golden rule. Step east to add time and step west to subtract. Because the Earth rotates from west to east, places in the east see sunlight first. This global puzzle requires countries to carefully organize constant hourly calculation changes. Unified clocks for whole regions. To prevent local clock confusion everywhere, the world is divided into 24 distinct time zones, each 15 degrees wide. One shared clock unites an entire region. For instance, India shares a unified time zone based on 82.5 degrees east. But what happens when we travel halfway around to the opposite side of the Earth? The calendar boundary line. On the exact opposite side of Prime Meridian, located near the 180-degree longitude line, lies the international date line. This pink line makes the calendar flip. It zigzags intentionally to avoid splitting countries, marking the exact boundary where the calendar date changes. Time versus date. Let's distinguish time zones from the international dateline. Think of the time zones as a carousel spinning through hourly sunbeams to change local hours. The dateline is a calendar flip that snaps new pages to change whole days. Let's track a global travel journey step by step to see it in action. Global Time Tracker. Let's track a flight. Leave London at 0-degree meridian at 12 p.m. on Monday. Travel east 60 degrees, which equals 4 slices, so you add 4 hours to arrive in Dubai at 4 p.m. on Monday. Continue traveling east across the international date line, flip the calendar forward, and Wednesday begins in Tokyo. The date line trap. Watch out for the common exam trap, changing only the hour. Don't be tricked by this trick. The date line flips entire calendar dates, not just hours. When you travel west across the line, you lose a calendar day. When you travel east across the line, you gain a calendar day. Time Traveler's Challenge. Let's test your new calculation skills with a challenge. Can you match these routes to their adjustments? Route 1 from London to India requires adding 5.5 hours. Route 2 from Japan to Hawaii crosses the date line to change the day. Route 3 from New York to Paris requires adding 6 hours. Flight time math. To master flight time math, follow 4 simple steps using the 15-degree rule. First, find your starting longitude and time. Second, count the 15-degree steps to your destination. Third, add for east or subtract for west. Finally, calculate your new local arrival time. Operations Tower quiz. Clear for takeoff. Check your geographic radar with this Operations Tower quiz. How many degrees equals 1 hour? 15. Where is the Prime Meridian? Greenwich. What changes when crossing the international date line? The calendar day. Why are standard zones essential? To keep our global systems synchronized. A word in sync. Ultimately, the time zones connect our spinning world. Though we share one Earth, we experience many different moments, and every hour is a sunrise somewhere. The sun warms us all at once, but our clocks dance to the spinning Earth. Keep exploring because the world is waiting for your next great geographic adventure.